Hello everyone, my name is Matthew. I work at Flick and I'm not very good at public speaking, but I'm trying to improve, and that's part of my learning journey. So I'm very sorry about what you're about to see. It is my best attempt to give a presentation with some spicy content. So I also want to make sure that there's some good discussions here. The main thing that any speaker would want out of a talk is to convince you of a different point of view and perhaps change your mind, and if I'm really good, maybe change what you do, and maybe that makes your life better. But remember, these are all just perspectives, and I'm just trying to change your mind. So I would love to hear yours. So I started talking about this earlier. I write Ruby for Flick. I love them. And why might what I'm saying be interesting to you tonight? Well, there's some new Git features which I've noticed in the last year, really, maybe 2 years. They may have been there for a bit longer, but I've just started playing with them as a way to communicate my changes to my teams. And I've also had feedback that I've given enormous pull requests to my team members, and that made it very hard to really tease out some stuff. So I've done a lot of thinking, and I've come up with some workflows which I hope will help you all in doing that. But I also realized that jumping to the tools is hard. So I've also smushed some beginning bits in the start of this talk, which are going to talk about refactoring. So that was me. The main thing that I want you to think about, if you take nothing else away from this talk, is before you plant your flowers in to your gorse-ridden bank, please take the gorse out, or at least shuffle it around so there's a tidy bit. Because when you have a little clear patch, those flowers really grow well. But if you just dump it in there, you make a ticket, put it in the backlog, you say refactoring, rewrite the foobar. No delivery manager, no one knows what that is. They're never going to prioritize it, and it's too late to get the value out of it. That's my entire thing. You can summarize it as that. Boop. Right, let's start with a feeling that I sometimes have. Who's had this feeling in code bases where they've worked? A few hands. Don't worry. It's the words poor design. They may feel like, but sometimes things get big and things slow down. This is actually stolen from Refactoring 2nd edition by Martin Fowler. Good book, really dry. So used as a reference a lot of the time, but from the beginning he's got this. And then he's got this graph as well. So who's familiar with the red line? Who's got the red line? Yes, I see a few hands. So it is possible, if anyone didn't see that, there were like 4, 5 hands that I saw shot up. It is possible to move from one line to the other line, and you can feel really good. It's all anecdotal, of course, but it's just a feeling that you get. I'm going to propose that the reason we design software is all about this. I don't think it's too controversial. We design software to reduce its cost. You want to be able to deliver things as fast as possible for as cheap as possible to figure out and respond to the market and to try to test things out. That's what we've been trying to do for the last 30 years. Just trying to get quick feedback loops that we can adjust our approach. So if we design software to reduce its cost, then the cost is the cost of changing it. Because the first edition of what you produced, it's not the last one. You need to build off that. And if you're going to look at the cost of changing software, the cost of changing software is actually about those expensive changes. There's trivial changes, they go out all the time. You do it, it's fine. But when the power laws are involved and you have something that is coupled to every aspect of the system, that's where it starts to get tricky. So there's the negligible things, but it's the expensive changes that you really need to talk about. And expensive changes are cascading changes. When I change this, I need to change this, I need to change this, I need to change this. Suddenly, I've changed everything. What am I going to do? Like, that's enormous. So, let's talk about coupling a little bit. That's something from university. Who's heard of coupling? I think everyone's heard of coupling. Who feels coupling? Who really gets it? It's like that idea of this understands this. Like, coupling is how things propagate. The knowledge of how two things are connected are what causes them to need to change. So, if software design is about reducing the cost, which is about the changes, which is really the big changes, and that's all about coupling, then I propose that software design is about managing your coupling. There's lots of other things that people have come up with, solid principles, but really it's about trying to make sure that things don't know about other things. So I've changed this graph a little bit. I've changed it. I've got less coupling and more coupling now. So it's not bad design, good design. It's just trying to take those things and convert them out. But initially it doesn't feel that way. Initially, you can get a lot more by making all the things know about the other things. And you get a real big boost right at that first bit. Because now you can show off something which has the complete feature set. But that's planting your flowers into your weedy garden. So initially you might feel one way, but in the long run, it's better to go with a loosely coupled system. But is coupling bad? I would also say no, coupling is not bad. Actually, coupling is a fight that you have inside yourselves. A great person I work with told me, inside you there are two wolves. And that's really what it comes down to. Like, you as somebody who is trying to make something as good as you can, have this fight between what do I do, and if you go all the way in one direction, the cost goes way high, and you go all the way in the other direction, and the cost is also high. Also, these are not my ideas. This is Kev Beck talking about microservices. So just stolen this crude picture. I'm sure he's okay with it. So I realize that it's very hard to say to everyone, hey, don't couple things together. Because when you're trying to avoid driving into the wall, when you want to turn instead of driving into the wall, and you get told, just look at the wall, you're going to hit the wall. So don't think about coupling. Think about the other side of it. Cohesion. Coupling and cohesion is all we have to care about in software design. Cohesion is easier to move towards than saying, I'll move away from that. So aim to maximize cohesion. Things that need to change, go together. How am I doing for time? Don't lock, silly thing. Cool, okay. I'll speed up a little bit. So cohesion changes with new requirements. So what are you going to do? Well, you get out your trowel and you get going. Refactoring's to the rescue. So very dry. I'm going to do this very fast because this is not the technology stuff, but it didn't feel right to just leave you there. So I also think that dumping a huge book and saying learn all these things is too much work. If you haven't done refactorings before, what you could do is you could say, wow, there's these things called, like these situations where I might apply a refactoring. And those applications of refactorings also have pattern names, and they're called code smells. So what I did with the refactorings book was I took all of the different refactorings and I listed out all the code smells that lead to those refactorings, and I just sorted them by the things that solve the most things. And it came out with the things that I use all the time. And so I'm just going to go over those briefly. But I'll zoom through them even faster if people already know them. So extract function, move function, introduce parameter object, extract class, and inline function. Slightly curated list of things that I think will improve the code around you. There are deeper, better ones. But if you have to start somewhere, these are cool. Who's done extract function? Hands. A few people, but there's a few people who haven't. So I'll just talk about it briefly. Extract function, all that means is make a new function. So in Ruby, that's def, the function name, give it some arguments, pull it out and refer to it. It's this diagram here. These are the smells that it fixes up. If you see a data class, so a class that doesn't do anything, you can extract a function and move it there to give that data behavior that moves with that data. If you have two things that look the same, duplicated code, you can take a fragment, extract it, reuse that thing. Mutable data, separate out the side effects. Functions are a great way to stop things from changing state. Comments, there's really good comments out there, but if you name it well, it actually reads better. It like zooms that right up. And long functions, you can shorten them out by pulling things out. So that is extract function. I'm going to go through the other ones fast because I saw a few people without hands up, and that one I thought was really useful. Alternative classes with different interfaces. If I have two things that are trying to do the same thing, you can just move functions between them. This is a safe refactoring. If you get out the refactorings book, or if you go to refactorings.org or the refactorings catalog, at the end of the talk I've got a link to those. It's got a step-by-step instruction list of what you would do, and it's sort of like putting on your seatbelt after a little while. You just move that function over to where it needs to be, and then you can reduce the number of duplicated things, or you can change protocols so that two things can be used together. Data class, already talked about it. Inside trader. If you have something that knows a lot about another class and you don't want it to know all that stuff, you just put the function where it needs to be. If you've got a foo class and you keep referring to it from your bar class to construct something else, well, construct it over there and just return it. Introduce parameter object. So this is when you have a huge list of things that you're passing into a function. It is not 5, might be 10, might be 15. It's getting a bit silly at 15. But if you have a huge parameter object, what if you just had one that you passed in, and if that owned all the stuff? Well, now you've got to name it, and giving a name to it gives it power. You can move functions there, and you can start to say, well, this group of things, they live together, they move together, it brings on utility of its own. So if you see a lot of things going into a function that's a signal, if you see data clumps are things like cents and dollars and GST. All those things feel the same. They should live together. There's already good classes that deal with that. Or if you've got things about a user, there's no perfect thing here. We need to adjust our systems as we go. Extract class. So that is, I have a large class of things and I just want to pull things out of there, put them into another place. You'd use that for large classes. Data clumps, again, primitive obsession. So this is a fun one. If I have a lot of integers that I'm managing and a lot of strings, I could just put them all in a class and name it. That gives it power, as I argued before. So extract class is a good way. If I'm managing that within a class, pull it out. There's overlaps here. Inline function. So this is when you've already gone all the way in one direction. Someone has thought that there's this grander way that your system should operate because of incoming new requirements. But we never got there. We almost got there, but for some reason the focus changed, or we found a better way to express that. Well, you just push it in line. If you have something, a middleman, a class that has nothing that it's doing, just passing stuff on, you just inline that stuff. Speculative generality, that's a cool one. If you've encountered that one, it's just a fancy way of saying there's just a lot of different components, and you can just melt them together. What I love about the refactoring patterns is when I came across this book, the code didn't look beautiful. It looked like my code, and it gave me a way out of that mess. That's why I loved it so much. But it's super dry. And if you're doing this, there's some things that have got your back, because you're making changes. One is you test harnesses, so you things that prove that the system still functions the way it did, and you get history. You can always roll back to something that worked. So here are some, I'll start with some hot take on the head harness, and then I'll mash into some real things in the Git history. All right, so I've bumped into a feeling that people have had at Flick, and I've grabbed some of these quotes out about things that they found were hard about a technology called VCR. So I said, I'm just going to read it out. Hey, back in Gilders, I've been getting bad vibes from people about VCR, and I'm not sure what makes them so terrible. Please pop in examples and of what's working against you. I'm going to take those examples, compile them together, and then see what themes emerge. Now, I quickly got busy and forgot to do that. So I'm just going to improvise a little bit. But I think they're all pretty good. Scenarios aren't always well described? Yes, I've had this. It can be hard to regenerate them? Yes, that's really hard. Someone manually edited a VCR? Well, you can't regenerate it now. It's been changed. Benign things like rename tests. Some VCR responses are so old that it's impossible for them to accurately be regenerated. So if anyone hasn't used that library, basically it sits there on the boundary of your system and it's recording the HTTP interactions that head out against real live systems. And if the data over there changes, then these things may become stale and be hard to get back to where they were. But I don't want to tell you to avoid driving into the wall. I just want to say test the coupling, which brings me back to the earlier thing. Coupling is not bad. It's just a way of making yourself feel better about what you're releasing out into the world, giving yourself a feedback loop. It's all about finding that feedback loop. Oh, okay, I should have waited. So here's my hot take. If you're saying to the people around you, oh, I want to go faster, these tests are holding me back, they're stopping me from releasing, well, I suggest you just remove them. And I'll give a better argument about that in a couple of slides. No, I'll give it straight away. So, I would say that VCRs are a form of snapshot testing. They don't describe things that affect our users very well. They describe the way a system behaves at a point in time, and you can introduce them if you want to make larger changes to move things around without necessarily having to couple yourself to the structure of your code. So they're a fast way of getting complete coverage of large swaths of code before you make those changes. So if you finished with that, then actually after that, I would say that the usefulness of those tests has sort of diminished. And at that stage, you should think about writing something that is more from the perspective of what customers are going to be hit by. Because if that test breaks in the future, and I see a good compelling story from a business case that says customers would like to see that they are billed on time or something like that, then I will go, oh, I better pay attention to that. But if I see, and the value of A is 3, I'll just update the value of A to be 4 now. And I don't know whether that's good or not. And the person who saw it, they might get upset. But like, if you rewrote things with customers in mind, then that is saving something that's really useful. I think, who else needs to be maintaining this? So that's my hot take. Throw them into the sun, start again, recreate them. They're cheap tests. Snapshot testing doesn't have to be VCR, that's just one library. You can actually just save entire bits of JSON out and say this equals this. You could do lots of stuff. It's just a way of getting speed. But, actually, I'll make one more argument. How much time have I got? Tell me. I got 10 minutes. Okay, wait, 30 minutes? 30 minutes? About that, okay. All right, so the next thing that I see a lot when people do tests is they've done the code, and now they just have to write the tests. I've finished, it's okay, I've got to write the tests. Now the problem with that statement is I think it's coming from a good place. I write tests because I'm good at my job. I write tests because it's the thing to do. But tests give you this way of seeing your code in action. They are the first implementers of your API. Now I'm not talking about some web URL. I'm talking about you've got these public methods on a class and these behaviors that you're expecting to be used. So if you've got a test that is in place and you start building it while using that test, you can actually see the API as it evolves. And if it gets big and clunky, you can be like, wait a minute, I should apply some of these cool refactorings. And then it becomes simpler. And it's beautiful because instead of promising the team that you finished and then feeling the pressure and then locking in that design that you've come up with, you've got that feedback early and you built something that could be loosely coupled. So, I got other arguments, but I won't go into those. Come get me afterwards. So the big problem with all this is that you end up with an enormous code review at the end of it. I want to change everything. So that's where some of these Git things that I've found come in handy. So Git is a great way of cheaply creating branches. You just create a bunch of them, and it's all right. So I've started creating these branches, which I've labeled prepatory refactoring, which is actually after the pattern that Martin Fowler put out in a blog post ages ago, because it's pretty cool. He seems to be ahead of these things. And the idea is, I've made these changes ahead of the feature that's coming. So refactoring specifically means I'm changing the structure of code without changing the behavior of the system. So when someone reviews this, they're going, oh, so it acts the same as it did. And when someone reviews this, what they're seeing is, oh, this introduces something new that I'm going to use and I can understand these from the perspective of the story now. But this doesn't mean anything from the story, this does. Of course, this looks very pretty because it's right at the end of the whole thing. Actually, what I end up doing is just trying to bolt for it initially because I don't always have the insight. So it's okay to start by committing things and continue to commit things, and you end up with this linear history full of things, and that's all right. So as you see, code smells large, class, parameter, object. You can introduce commits there, and that's okay. And what's nice is interactive rebase has you back. As long as you do it before you make the changes that depend on those changes, you can push them right down to the bottom of what you're doing. So in this case, at the end of an interactive rebase, because it's an immutable history, I've left the old one here. So if I was pointing at my prepatory refactoring, no, if I'm pointing at my feature branch, I haven't got to that bit yet, and I wanted to reorder these, if I run get rebase interactive, I'm presented with a text editor which contains lines. It's going to execute those lines in the order that I give them. I just flip them around, put the feature stuff to the top, refactoring to the bottom, boom, it's a different order. Oversimplified, of course, here be merge conflicts and other things. It's okay because there's a -- abort. But I'm not going to make my presentation about aborting a rebase. If everything goes wrong, you can always get out of it, and it's okay. It's okay. So here's a cool feature, which I've only noticed in the last year and a half, and been playing around with. And that is an auto squash rebase. Auto squash rebases, they key off something called fix-up commits. So get commit, if you've added some changes, and you're like, actually I should have done it back there. You can run get commit fix-up with the little hash, and it's like, okay, I'll make a special commit. And it ends up looking like this one. So you get new commit hash on top of stuff, and then something that's sort of decoration. And squash, and it sits there in the history until you do an auto squash rebase. So on the next rebase, it just smooshes those together. So this is a before rebase, and this is an after rebase. Notice the commit hash changes, and everything's rolled up. So yeah, I work in a messy way. I figure things out afterwards, and I try to make it nicer. And that's just sort of like exploring a problem, really. And I mean, if you can do it the first time, that's amazing. And I'm really, but this is me. So I'm just sharing these techniques. So the next part to making that stack that I was showing you was creating a branch. If you create a second branch, you just give it a commit. So in this case, if I'm making a preparatory refactoring branch to sit on top of my feature branch, mash on a commit on the end, boom, you've got a stack. And now, here's the next beautiful bit. If you are moving on volatile upstreams, people are merging work and you're trying to rebase on top of it, if you use this update refs configuration in your Git, it will start to, in your rebases, add this thing, which moves the branches with you, between you and the base branch. So if I have 2 branches or 3 branches and all of them are based on each other, it brings them along for the ride, just moves them over. So you end up with this sort of traveling stack of stuff. Of course, merge frequently and often, because other people can benefit from these things. The sooner you can get these things out, the better. Sometimes I'm doing a whole pile of refactoring, but my feature isn't ready. I'm like, this feels like the right kind of size to share at this stage. So I'll share it, and I'll get the feedback, and then I'll know early from my team members whether that's okay. And it helps, cleans things up. So you end up with PRs that are based on branches. And these were the things that I asked you to do with Git. So if you run git config global update refs, auto squash on your rebase, you'll get these things. And these are the 3 habits that I'm going to suggest that you bring into your workflow. Create branches in your history so that you can share those things early. You should fix up commits when you realize, whoops, I didn't run Rubocop back then. I'd better go and push it back there so that my linting rules are happy. And rebase often. And if you do these 3 things, it's going to change your life. But what about sharing with other people? Well, there's this branch thingy here at the top of GitHub. So when you go to share your work, you can choose what you're basing it off. So always remember that the thing at the bottom goes against master, but the thing on top of that has to go against your preparatory refactoring. The reason you tell GitHub this is, if you're using GitHub, if you're using GitLab, it's very similar. The reason you do this is because you want the diff to be just the stuff that you're asking your reviewers to do. These are all kindnesses to your reviewers so that they can give you feedback about the changes that you're making without all the clutter. So doing this is pretty cool. And it also tracks when that base branch merges. So it goes, you can see it in the conversation history. You can see at this stage it got merged. So you end up with something that sort of looks like this. I stole this off another blog and I didn't credit it. I'm very sorry, but it's generic enough that it could be anything. So, conclusion. How am I doing for that time? I did a whole pile of these where it was like live examples, but it was like an hour long. Oh, cool, we're close. All right, so software design is about managing coupling. Everything you do is about managing coupling, and that is because you want to make stuff as cheaply as possible to get that feedback loop going, get that flywheel, and feel the speed in your code bases. You can adjust cohesion with refactorings. There are well-known techniques that apply these safe things. Break up your work, and then throw your broken tests into the sun. If you're saying they're broken, well, just make some new ones. Cover that stuff. Feel like the tests are giving you good feedback about what is good and what is bad. But if you feel like they're broken, you have my permission to press that delete key. And that's it. Pull some weeds before you plant your flowers. And those are the resources I promised. So, refactoring guru, really nice person's gone and put all this effort into writing up a quick reference. I really like this. If you want a faster version of that, this is really cool to have on the desk. And Martin Fowler actually on refactoring.com actually published the catalog, but it doesn't have the code smells. So here we go. But if you forget all that, just find me on Ruby NZ. I'm Hey Matthew. Or ping me on debug@matthew.nz and I'll tell you about these things. And we'll keep the conversation rolling.